Welcome to episode 11 of the David Bernard Podcast. Today is June 22nd, 2021. We're 3 weeks into this very young hurricane season, and we've already had a storm. So we couldn't get through June without a storm. Hopefully we're going to get out of June without having another storm. We still have a week to go, so we'll see how that turns out. But today I thought we'd talk about after Claudette, the impacts from Claudette, the forecasting of Claudette, and we're also going to get into a little bit more analysis about what could be ahead with the hurricane season. Today, my guest is going to be Eric Blake. He is a senior hurricane specialist at the National Hurricane Center in Miami. But Claudette was definitely an interesting storm. A couple of points to make. We had an idea that this Gulf storm was going to form. In fact, the global models, both the European and the American model, the GFS, were hinting 10 to 14 days out that there could be some development in the Gulf. It took a long time for that process to happen, and we're going to talk to Eric a little bit more about that. It was also one of those typical June Gulf storms where all that weather was on the east side, and we kept talking to everybody saying, hey, look, somebody is going to get a lot of rain with this, and somebody's not going to get anything. And that's basically how it went down. But the precision of the models, especially 48 hours out on the rainfall accuracy, was quite amazing. And we were able to really prepare people along the Mississippi Gulf Coast and in southeastern St. Tammany Parish that there was a high risk of extreme rainfall. But that sharp cutoff was something else. If that storm had been 20 miles to the west, the disaster would have been even larger than the hundreds of folks who had flooded homes in and around Slidell. That would have been right over Orleans, Jefferson, and St. Bernard with an even higher population and a greater economic impact. That did not happen. Of course, a lot of people talking about Claudette being named when it was over Homa. It actually did not acquire complete tropical characteristics until it reached the coastline of Terrebonne Parish. And we're going to talk to Eric about what that means and why that exactly happens. Remember, you can watch this podcast as well. We have a video version on our website, fox8live.com/David. And if you're watching the video version and you want to finish it off with the audio version, there's an audio version on our website as well, but we're on all the podcast apps. So whatever other podcast you listen to, just search for David Bernard Podcast, and you'll be able to find our episodes there. Again, this is number 11, just having kicked these off a few months ago. Finally, don't forget about our website, fox8live.com, and our weather and news apps during the hurricane season. The power goes out, and you've got a portable battery charger. You'll be able to continue watching our coverage if you lose cable or, again, if you lose power, a really important tool as we head into this hurricane season. So without any further delay, let's bring in our guest today, Senior Hurricane Specialist Eric Blake. Eric, welcome to the podcast.
Good afternoon.
Glad to see you here. We got to start this off by letting everybody know in Southeast Louisiana that don't know this, that you are a local kid.
That's right. I was raised in Metairie, and I graduated from Mandeville High School.
And obviously growing up in Hurricane Alley, I'm sure had a lot to do with how you ended up at the Hurricane Center.
Definitely. No, I guess you go back and look at the previous Louisiana season of record, 1985, before last year, of course. That was really that really got me into hurricanes. We had back-to-back hurricane threats, just like we had last year in Louisiana. And it was, Danny, Elena, Juan. Then you had Kate late in the year. It was definitely memorable.
That was an unbelievable season. I do remember that. And I remember Elena, because I'm a little bit older than you, a little bit, but I remember Elena and watching that when I was in Houston. And that was the one to remind everyone that was coming our way, and then it turned back to Florida, and then it came back. It eventually went into the Mississippi Gulf Coast.
Yeah, it did a big giant loop in the northeastern Gulf of Mexico, and the hurricane forecasts, weren't as good back then. So people really had no idea. It's all the way from Tampa to Louisiana. Nobody had any idea where it was going to be, and it eventually strengthened into a major hurricane and did quite a bit of damage and made landfall east of New Orleans.
And one was the big flood that came in October, and then we had Kate, which, until recently was kind of a benchmark for late season Gulf storms, and we had Zeta last year.
Yeah, yeah, yeah. If I remember correctly, Kate was around Thanksgiving, so it was even later than Zeta was.
Yeah, really. That was a wild season, a good one to bring up and remember. And was that a La Nina that year?
It was kind of a coolish year. It actually had
Okay.
some of the same similarities to 2020.
Exactly, which kept that's the La Nina is what kept us going so late into the season last year. Well, let's jump ahead to 2021, and I was hoping we would get through June without a storm this year. It didn't happen. Is it uncommon to have a storm during the month of June?
No, we average a June storm about once every other year. Recently, they've been happening a little more frequently, but June storms happen all the time. It's been very active in the Western Hemisphere overall. The Eastern Pacific's already had four. The Atlantic's up to three. So it's I think we've actually tied the record up to the end of June already. So it's been busy.
So June storms, they're not your traditional storms all the time like we might see deeper in the hurricane season when we get to August, September, and October. I tend to say, they tend to be sort of messy, and Claudette was one of those messy storms. Why is that the case, and particularly with Gulf storms, which where they usually are, or say off the Carolina coast?
Sure, it's really a combination of a few things because in the middle of the season, those big storms that you'll see come from Africa, that's not where Claudette came from. It kind of came from a trough of low pressure that was very elongated at first, and those things take some time to get organized. Secondly, the water temperatures aren't as warm as later in the year, so there's not as much instability, not as much energy for the systems to work with. And thirdly, there's more shear. So all these things combine together to kind of keep these systems. It's fairly rare to have a June, hurricane landfall in the United States, and they tend to stay tropical storms.
And so Claudette was, I use the word complicated. I mean, only complicated from the standpoint of how it developed. To me, when I was looking at it seemed like, well, first of all, well, and we're going to talk about computer modeling later on, but computer modeling did a good job of at least of showing us a signal quite a ways out, at least a week and a half, maybe almost 2 weeks, that there might be something coming out of the Bay of Campeche into the Gulf of Mexico. Did this have something to do with the Central American gyre? We started hearing a lot about this last year. This is sort of the new sexy weather term that's in the public lexicon, and it's the winter equivalent, I say, of the polar vortex, something that you and I have known about for a long time. But, some website picked up on Central American gyre, and it became commonplace in the last year or two. Was that one of the contributing factors to Claudette?
It was, and you have to go back and I think the first mention that so the Climate Prediction Center puts out a 2-week tropical cyclone forecast, and as early as the first day of hurricane season, we noted that there was the potential for a storm to form in the Gulf. It happened a little bit later than we thought it would, but these gyres are somewhat predictable because they're linked to something called the Madden Julian Oscillation. Uh, every 2 or 3 weeks, there's a better chance of tropical cyclones, and then every 2 or 3 weeks, there's kind of less of a chance. People are familiar with tropical waves that move from east to west. Well, this Madden Julian Oscillation moves from west to east, and it's much more global in scale, and it moves slower than a tropical wave. And we had a more significant event coming through that was more predictable. So this MJO, as they're abbreviated, moved east, helped form this broad area of low pressure near Mexico in the southwestern Gulf of Mexico, and then it just kind of sat there for a few days. And gosh, was that a week ago now? It seems like a week ago now. Um, uh, a tropical wave moved up into that system, and it kind of moved, kind of revolved around, and there was an upper trough nearby, and that's what kind of spawned that area of low pressure. it took a long time to get organized. It was just this big, broad thing that really only got organized right around the coast of Louisiana.
And it's real common to have, well, first of all, when you talked about the Madden Julian Oscillation, so basically it just, maybe for people to understand a little bit more, that it creates big areas of rising air, right? And rising air is conducive for thunderstorm development. So that's what spurred that on.
Yeah, that's right. So it's just large scale areas of rising and sinking air, um, and especially early and late in the season, it can be very impactful because climatology in the Atlantic is very peaked. The chances of storms in June are a lot lower than in September, but that MJO can kind of kick up the June background favorability to levels where you can get storms to form.
And the thing with Claudette is, and what happens with a lot of these Gulf storms, and you said it took a long time for it to get going. A lot of times, because it's so early in the season, you still have the westerlies, the jet stream that can be rather far south, that can create wind shear, unfavorable conditions in the Gulf, and that can also involve dry air getting pulled in when you talk about upper level lows, which aren't favorable generally for developing tropical storms or hurricanes. And we kind of had a little bit of all of that going on at the same time.
Yeah, it was just, you had it right earlier. It was just messy. And it took a long time to get organized. And finally, gosh, was that 5 days ago, six? Finally, enough thunderstorm activity formed near the center and formed kind of this broad area, kind of tightened this broader area, low pressure, right near, right near Homa almost. It was kind of interesting. Those types of storms happen. We've had tropical storms form over Louisiana before. So Louisiana's mostly water anyway, especially south of the lake. So yeah, so that's how they can form there.
That's something definitely to remind of. Dr. Jeff Masters, who was on my podcast a couple of weeks ago, commented on one of your Twitter posts today. You had a little meme you had put up about Claudette, how Claudette loves the land, the water, not so much. By his count, he could only show 12 times since 1851, which is the historical record for tropical cyclones in the Atlantic, that a storm had formed, quote, over land. So indeed, it is rare, but important to point out the topography going on in Louisiana and other places like South Florida is another example where things like that can happen.
Yeah, you see those in South Louisiana is known for its warm, swampy land, and that can be conducive for storms to form. Now, you wouldn't expect hurricanes to form, but it's certainly enough for a tropical storm. South Florida, they've happened there, and they've also happened over the Yucatan Peninsula of Mexico. Very flat and surrounded by very warm water. It's been several years ago now, but we've had systems that kind of move over land. The friction tightens them up, and then you'll get that well-defined circulation that qualifies them, and they can already be producing tropical storm force winds, so the instant storm.
And of course, one extreme example, and I mean, it's not exactly the same, but I do remember, and I was in Miami at the time when Katrina struck. I remember Katrina, as it moved over the southern tip of the peninsula, it actually, I don't know if it officially was strengthening at that point, but it seemed to me the structure was improving even when it was over the Everglades. And part of that was the storm is pulling in air from the Atlantic, the Gulf, the Caribbean. So in that case, I don't think it had much of an impact either.
Yeah, Katrina was an interesting example where it certainly didn't weaken very much at all. What happens over land is sometimes land has more friction than water, and it causes more convergence, and sometimes can actually result in temporary strengthening. Faye of several years ago, gosh, maybe 2008 now, actually happened near Florida. Another one of these types of strengthening over land. So it happens. It's fairly rare, but definitely occurs. And in Hurricane Danny in 1997 was a very weak system, and then started to strengthen over eastern North Carolina, much like Claudette did.
Yeah, I remember Faye, 2008. You are correct. And that was, I believe they had hurricane force winds over Lake Okeechobee as that was going across.
They had at least gusts. It was a pretty notable event.
Yeah, exactly. So, yeah, so anyway, that kind of answers the question for folks that were a little bit perplexed as to why Claudette didn't get the name, so to speak, even though it was on the Louisiana coast or basically over Homa. Let's talk a little bit about computer models. And, you know, that's been a real fascinating evolution for me since I began in broadcast meteorology in 1992. Obviously, things are just exponentially different than they were 30 years ago. And as a forecaster, sometimes I want to get your opinion on this, but sometimes I run the risk of looking at computer models a little too much. And we can get into the public looking at the computer models on the internet, but actually trained professionals, they're wonderful to use, but sometimes I forget maybe to look at the bigger picture, like what's actually happening in the atmosphere when we're predicting these storms.
Yeah, it's computer models can be a little bit of a double-edged sword. Um, back when I was in school, the models weren't very good, and if you looked at the models too much, you had what some people term meteorological cancer. You were forgetting the meteorology and just looking at the model, and the model is not reality. But as the models are getting better and better, you have to take them more seriously, and sometimes they see things that the humans will miss. We can't we can't integrate the equations of the physics equations as fast as the models can, and they're quite good. So what I try to do is look at the most historically reliable models. We at the Hurricane Center, we verify them all from the bad to the good. Try to get a good understanding of over the past 3 years or so, which models have done better than others, and then start from there, and then try to apply good meteorological reasoning. Well, this model looks right because of X, Y, and Z. Sometimes kind of the first rule of thumb is to when you have a bunch of generally good models, a consensus of those models can often cancel out those errors, and is a good place to start. That actually worked out pretty well for Claudette because there were a couple of models that didn't show much strengthening over North Carolina, and there are others that were becoming quite strong, 60 or 65 miles per hour. And in this case, the weaker models ended up winning, but a consensus of the approach was pretty good. And so I think you can run the risk of looking at too many, but if you're looking at generally the historical ones and try to balance it with your solid base in meteorology, I think you're generally okay.
I think one thing that's been a little bit interesting in recent years are some of the newer high resolution models and their skill at well, I'll let you answer that. What their skill is at perhaps predicting genesis, and that would generally have to be limited to certain sectors of the basin, I guess, particularly close to the land, depending on which model you're looking at because of the grid size. But it seemed to me that those used to not be considered as much, but maybe are a little bit more in favor and paid a little bit more attention to, and maybe particularly with intensity changes.
Yeah. So with the development of the H-Wharf about 15 years ago now, that was kind of the next generation of these high resolution computer models. Now that they can incorporate Doppler radar data and reconnaissance data as well. And so we're actually getting a more realistic picture of what the hurricane inner core looks like. Before 10, 15 years ago, we were kind of using what an idealized vortex. But an idealized vortex will only get you so far. You really need to know, what are the model asymmetries? What's going on that's different than normal? And so we're starting to get some of that data in there. And we saw last year where the HWAR produced very realistic forecasts after the NOAA hurricane hunters were flying in there and got as much of that in situ reconnaissance, flight level wind, dropson, and radar data. It's kind of been a revolution over the past 10 years. So, kind of in the early 2010s, there were studies run that put in this type of data. And the model wasn't able to handle it, whether it used an idealized vortex or a so-called real vortex. A lot of times the idealized vortex would verify better. But now the data assimilation is so much better that real data is making the forecast better. And that's why you'll see oftentimes we'll try to fly the NOAA hurricane hunters with the special Doppler radar as much as we can to get the best possible forecasts.
And on that note, I always tell people, we're only as good as our last forecast. That's what I always say. It's like, I can have a great forecast this week. Next week, something I may completely blow and fall apart, and I almost feel like I'm starting over. But I know you guys don't look at it that way because you look at all your forecasts, and hopefully it comes out to most of them are pretty good. And I would say, my opinion is they are. Okay, but we all have those days. And I think the same things about a model, right? And I've got viewers all the time that, for years it's been the GFS, which is the Global Forecast System, the American model, more or less, and then the European model. Have sort of been the two lead global models that have been out there. And, people are kind of obsessed over, which one is better. And a lot of improvement has been made to the GFS model the last 2 or 3 years. I would say there's been exponential leaps in that model compared to the past 5 or 10 years. And in this particular storm, I would say the GFS won this one, did an excellent job. I'm not an expert in computer modeling, and I don't sit there and do all the, what am I trying to say? Hindsight forecasting, verification on which one did better. But gosh, particularly the landfall and the rain forecast with the GFS, it was shockingly precise. I would say days out that there would be this one particular intense rain band in southeast Louisiana and the Gulf Coast, and really in the final 48 hours, that along with some of the high resolution models were insisting that was going to be over Hancock County and potentially basically on either side of the Pearl River, including Slidell. What were your observations on that?
Yeah, I agree with you that model did quite well, especially late on. It had a little bit of a false alarm on the initial structure, though. It formed, almost all the models were forming the system too fast, but it had a pretty reasonable forecast of the hazards. That heavy rainfall, kind of that big, strong band that you'll see in these types of hybridy type of situations. There's, tropical storm characteristics, but also some subtropical characteristics because there was an upper trough nearby. It wasn't it wasn't a Laura or Zeta by any stretch of the imagination. But even tropical storms can produce quite intense rain bands, and that's what we saw over St. Tammany and Hancock parishes / county.
I've got one of my mentors has always said, his saying is precision is the enemy of accuracy. This is Brian Norcross, and it's something that I've adopted, and certainly when it comes to tropical forecasting. People are often, especially with this storm in Claudette, I had people saying, is it going to flood here? Is it going to do this? And, the best I can do is say, yes, it's going to flood. This is the likely area it's going to. But for me to have gone on air and say it is not going to flood in New Orleans, we're not there yet. That would not have been responsible. Even though those models, the final 48 hours, really almost down to like 5 or 10 miles nailed where this destructive flooding rain band was the other day, we still can't communicate that way. We still can't give those kind of specifics.
You're right. I mean, even the best models, we can't tell you what parish is going to flood. We just can't. You might have a range of a few, but I was really impressed by some of the high resolution models as well. At first the rain rates were not very high, and then it kind of picked up just as the model said. And then that night, I was working the midnight shift that night, and then you saw this really intense band set up, near Slidell and mostly, you know, far eastern areas of St. Bernard parishes, and then quickly, not quickly, but in a few hours, thankfully, it moved to the Mississippi Gulf Coast. Otherwise, it could have been much worse.
Yeah, definitely. And that's one thing I noticed during the day is that the rain rates weren't really anything. But the thing to watch was there was this insistence that there was going to be some kind of increased convergence or whatever to increase those rain rates over Mississippi and Slidell. And that's indeed what happened. Last week we had the National Hurricane Conference here because, hey, what better place to have a hurricane conference than New Orleans in June? But for folks that don't know, it's usually in April. Okay, we usually do it out of season, but because of the pandemic, they wanted to try to do it in person, and fortunately, it actually worked out pretty well. Dr. Phil Klotzbach was here, and I talked with him on the podcast. You know Phil quite well, correctly? You guys go way back.
Yeah, we both went to Colorado State and worked under Bill Gray, so we talk all the time about hurricanes.
And so I asked him, and he does this seasonal forecasting that he's picked up from Dr. Gray and continues to this day. But I was just getting his observation on the state of what he thought the atmosphere looked like across the main development region between Africa and the islands, and just overall. Is there anything that you're seeing right now that's caught your eye that, or maybe raising your eyebrow just a little bit?
I don't see any reason to really, change the expectations from the forecast so far. I mean, we'll put out another NOAA seasonal hurricane forecast. They're usually in the first week of August. But but so far, we've seen a lot of storms form, and that doesn't necessarily mean much. But what I'll be looking at over the next several weeks is to see if any of these African waves can spin up. Because when you get early season African waves to spin up in the deep tropics, oftentimes that's a clue that the hurricane season is going to be busy. Now, we don't exactly know where, but 2020, I think we had 2 of those African waves form before August. And that's usually not a good sign for the season. The atmosphere is retaining a lot of those La Nina characteristics, even though it isn't in the tropical Pacific. And we're just going to have to wait and see whether that sticks around. So far, I haven't liked what I've seen in June. That's for sure.
Well, great. Thanks a lot for giving that good news. I guess I should have asked your opinion beforehand, but I had a feeling what you were going to maybe say about that. Yeah, because I even on the satellite, I think I was looking this morning, there's a pretty strong wave that has come off, and I know you guys were tracking one east of the islands, which, may or may not have much of a future, but the fact that there's actually some defined trackable waves, I think is the point that you're getting at.
It's early to have very strong tropical waves, and usually the atmosphere doesn't let it happen in June. Usually the shear is too strong, or there's just not enough instability. Tropical Atlantic is still relatively cool and doesn't peak for several months. So we'll just be watching to see if any of these waves. I talked a little bit about the Magellan Oscillation earlier, and it looks like for about the next 2 weeks, we're kind of in that favorable mode, and we'll see if, over the next 10 days or something, if we can get any more Gulf or Caribbean activity, and then look a little farther east after that. It's, at this point, we're kind of in crystal ball phase, because it's just, there's not a lot in the model guidance, and trying to pick up on these signals is very weak. So it's just really large scale pattern recognition that sees that, the chances seem to be higher than average, but since the chances are pretty low in any given week in June, it might not happen even if the chances are double average, if that makes sense.
And you were saying about La Nina. Last season we had the La Nina, and that is what really helped to keep the hurricanes going super strong deep into the season. In fact, ironically, was Iota the last? That was the last storm of the season, right? Or is it Eta?
I think Eta, right?
Yeah, Eta. Okay, right. Iota, Eta, right. And which is why we're getting rid of the Greek alphabet, because I can't remember it anyway. But ironically, Eta ended up being, I believe, the most intense, or at least tied maybe Iota for the most intense storm of the season.
Um,
Yeah?
I think Iota finished with 135 knots, and that was the strongest.
Okay.
And I think Ada and Laura both had 130 knots.
Okay.
That's just going off the top of my head now.
Well, but at
But
any rate, Iota was, right. The point is they were there at the end of the season, and they ended up still being some of the most intense storms. So that La Nina kept it going. There's less wind shear over the Atlantic, and that promotes more thunderstorm development. And you said there's still some La Nina signals out there. Is that more of a case of just kind of a hangover in the atmosphere, and not necessarily that there's a strong La Nina out there, but just that we haven't had a big shift in the oceanic conditions in the Pacific to make it unfavorable?
yeah, so those La Nina conditions have a tendency to linger. Um, they're even though it's not really being forced uh, by the waters. There's no real sign of a lot of. So what it's going to take to change this is really anomalous thunderstorm activity. And we haven't really seen that anomalous thunderstorm activity in kind of the tropical western or central Pacific. Now, if that returns, maybe we'll get maybe that hopefully by the peak of the season, some of those less favorable conditions will come for the Atlantic Basin. But we haven't seen it yet, and I thought it was good to touch on. 2020 was a special year in many respects. The end of that hurricane season blew away the busiest that we'd seen. If you remember, we had five major hurricanes form, Category 3 or greater, after October 1st. The record in the Atlantic Basin before that was two. It was that end of season activity was almost unheard of, and to have a system hitting like Zeta, that's more of an August or September type of system rather than so late in the year. So I definitely want to see those La Nina conditions fade away in the atmosphere, so we don't just keep on going like last year.
Yeah, I mean Zeta just when you thought it couldn't intensify anymore, and again, I guess we should have learned our lesson from the previous 6 or 8 weeks and what was happening.
Yeah.
It just kept getting stronger. I mean, and I guess the only thing that saved us is that we had this anomalously fast-moving Gulf hurricane, especially because it was so late in October, which is typically not the case. But definitely some crazy times.
Yeah,
So
if Zeta had been 20 or 30 miles to the west, it would have been much worse for the city of New Orleans. It was actually a benefit to go right overhead because the strongest winds were east, and so they kind of lashed the Mississippi coast more than the city of New Orleans.
yeah, I
It
mean,
was fortunate in many respects.
I think Bayou Bienvenue, there was maybe a gust to over 100, but then there wasn't anything close to that when you went to Jefferson Parish and out toward the airport. And that's a topic for another time. I've done a lot of stories on the lack of major hurricane winds in the city of New Orleans over the past 100 years, which have kind of been non-existent for the most
Keep
part.
it up. Let's keep it going. It's been 100. It's been 100 years since Tampa's had a direct impact. So just keep those streaks going. I don't need those at all.
We're quickly losing streaks, though. But yes, let's keep the ones going that we can. I kind of wanted to ask you on a more broad topic now. It's just some interesting news that has come out in sort of the climate world in the last month or so, and it's about the Atlantic multi-decadal oscillation. And some of our listeners out there who are way into the weather world know what we're talking about, and some may not. But this is the observation that has been made by a lot of researchers that the Atlantic Ocean hurricane activity basically operates more or less on a period of an active and an inactive state on a broad scale that can run anywhere from 25 to 40 something years, meaning above normal activity or below normal activity. Of course, within that 25 and 40 years, you can have microclimate signals, El Ninos, La Ninas, that can produce a little bit more some years and a little bit more. But if you look at it on average, you've got these, broad years of active and inactive periods. And this was something that I know that Dr. Bill Gray was really central to some of his observations and research that he made at Colorado State, who you studied under. Dr. Michael Mann, who is one of the better known climate experts in the country, has hypothesized in a recent paper that no, the AMO, the multi-decadal oscillation, doesn't really exist. And do you want to explain really quickly what his thinking is on that?
Sure. So he was thinking that a combination of volcanoes and other um, sulfate aerosols from pollution were really responsible for um, kind of the quieter decades of the 70s, 80s, and 90s. Um, you know, rather than some sort of internal ocean oscillation. Um, I I've thought about this a lot. It's it's I mean, I really just need to see more. I mean, I need to see more work being done on the topic because I have a lot of questions. I was just like, well, so was it a combination of volcanoes? Was it what specific? There's always African dust. I mean, what specific output and what chemicals? I mean, you would think that this could be measured, and it was just so abrupt after the 1969 hurricane season that things kind of quieted down. But there weren't, 10 volcanoes, and the lack of emissions happened then. So, I mean, is this a? I don't understand it yet, and that's really the reality. It's possible. I mean, and it's if that indeed is the case, you know, it's a question of, well, are we hoping for more volcanoes to erupt in the deep tropics for the Atlantic Basin? Why do the volcanoes only affect the Atlantic Basin, and you don't see this type of impact in, say, the Eastern Pacific or the West Pacific? I just think there's a lot of questions to really go through uh, before it becomes a really uh, established hypothesis, if that makes any sense. I mean, it's provocative and it's interesting, but it's just not. There's not enough there yet for me to totally buy into it.
Well, I mean, and that's the great thing about science, right? Is that we're always asking questions, and we don't know everything. We like to think as humans we know everything, but we don't, and we're constantly learning and evolving on this. So, what this means, though, for the bigger picture is, regardless if that is true or not, there's the other background situation of greenhouse gases and global warming, and more specifically, ocean warming, which, I mean, there's no argument there. The oceans have gotten warmer. And so, whether or not we're in this multi-decadal pattern that has been the thinking for a number of decades now or not, we've got these warmer oceans to deal with. And I think Kerry Emanuel, a lot of his research has focused on, well, what's the end result of that going to be? And obviously, with a warmer ocean, you're going to get a different outcome with storms over the long term.
Yeah, and I'll just return to the Michael Mann theory for 1 second because it does matter whether he's right or not. Because so we've been in the so-called active Atlantic mode since 1995, and the previous quiet mode was about 25 years. Well, we're past 25 years now. So how long will this last? And if there's really not some sort of mode, do we really expect it to go back to quiet? Or are we more? Is more of the normal to expect since 1995? And that's something I don't think anyone really knows. If you go back and look before that, the so-called active mode was from about 1926 to 1969. That was a long time. That was 40 something years. It really matters whether we're going back. I mean, I would sure like to go back to that quieter Atlantic. But there seems to be no guarantee that we'll get back there. Um, and then going to your the global warming question, there's a variety of things. I mean, yes, no doubt it'll be warmer. But what's more interesting is what will happen with the vertical wind shear profile over the Atlantic Basin. Despite the warming that we're expecting over the Atlantic, there are quite a few models that show increased wind shear. So it's kind of competing factors. Yes, the waters are expected to be warmer and warmer, but there's expected to be more wind shear. So those are kind of fighting each other. Those are really fighting each other. Those two conditions in terms of how strong systems will be. There is some tendency to think that the hurricanes will be stronger in the vicinity of 5 to 10%. And 5 to 10%. So that's like, if you have a 100-mile-per-hour storm, that's like 5 miles per hour or 10 miles per hour. That's barely in our understanding of. We can barely observe that now. And so that's relevant, but it's also, you kind of have to combine all the things, because you also have so with global warming, you also have sea level rise. And so if you're getting a few feet of sea level rise within the next 100 years, that is pretty huge for the city of New Orleans, because let's say the storms are a little stronger. There's some idea that the rain will be significantly heavier. I think the latest study I saw was about 10% more. 10% heavy. So when you kind of combine all these little things, it really does add up. One thing that, one of the studies, a lot of studies have shown that there's the expectation is for fewer or about the same number of storms overall, but they could be stronger. It's certainly not settled science or anything like that, because the next generation of models is showing something a little differently than the others. Others were showing more of an El Nino-y state that's kind of linked to producing that higher shear. But we certainly haven't seen an El Nino-y state last year. And so we just have a lot to learn. I still think even in, let's say the models are true, and we do, in 50 years, we do have that warmer atmosphere and more shear, there'll still be this El Nino, La Nina oscillation that happens. And in these La Nina years, you will have the risks, significant risks of, very warm water, reduced shear in that time, along with the other surge and rainfall risks. So it is something to pay attention to.
Yeah, I mean, really, what I've been preaching for the last 10 years when it comes to all of this stuff is, every year the greatest existential threat to us here in Southeast Louisiana is a catastrophic hurricane. And I just think mitigation and adaptation is the way to go. We can't be sure about the climate models. We can't, be 100% sure about what that's going to do to the atmosphere. All we can really control is how we're living, how we're building, and how we're protecting communities. So that's where I'm coming from, at least.
Yeah, I mean, if 2020 showed us very keenly how the risk to Louisiana, New Orleans in many ways lucked out last year, despite being in a cone every month, it seemed like.
We were,
but the worst of it missed, and I think what people have to understand is that that the worst area is generally near and just to the east, and it's not a huge area, but we're not that good 2 days out to tell you who's going to get the worst of it, and that's why it's kind of these larger hurricane watch and hurricane warning areas. And when we say Zeta was one wobble away from disaster in the New Orleans area. It wasn't great as it was, but it wasn't disastrous by any means.
Well, and just to sum it up with Zeta and Claudette, I was talking with a friend today, and I said, if that rain band had been 20 miles farther to the west, it would have been worse than anything that happened to us in 2020. It would have been. I mean,
yeah. For the New Orleans area, I think you're right.
Yeah, I mean, because Zeta was, we had some wind damage. It was a power storm, and we avoided significant surge and rainwater flooding. So it goes to show you, it doesn't matter if it's the 40-mile-per-hour tropical storm or potentially the fast-moving Category 3 making landfall in Terrebonne Parish. I think we answered this at the beginning, Eric, but I always like to end with you always knew you were a weather geek when. And I think you referenced the 85 season, but I mean, was there anything else that was rumbling in your head before then?
Oh, I mean, I think I knew in the 85 hurricane season was one. I mean, maybe, I mean, I've known for a long time. I think it was solidified when I was, tracking hurricanes in junior high and high school, and other people were doing a little more normal things. On my lunch breaks, I'd be trying to catch a sneak peek of the Weather Channel. It seems like ancient history now, but in 1997, I actually worked for WVUE for a
That's
while.
right. I totally forgot about that. You were with Bob. I completely forgot about that. One of his star interns. He talked about that to this day. But of course, that shows you how much younger you are than me, because you wanted to get a glimpse of the Weather Channel. I was in the 70s, and so my first storm I tracked, I was 8 years old, was Hurricane Anita, a Category 5 in the Gulf on my magnetic tracking chart, and I had my NOAA weather radio, and I would listen to the entire thing until it came around to the tropical weather outlook, and I would have to listen to the marine forecast and the farmer's almanac and everything else. And I knew when it would update each day, I'd sit by that weather radio waiting for that to happen. So, but
we're not terribly far from that era. I mean, I was doing the same thing for Hurricane Opal in 1995. The advent of the internet has changed weather information largely for the good, because now there's a lot more access. I mean, of course, there's problems there, but it's you certainly don't have to wait for the weather radio to rotate around for 5 minutes till you find the information you're waiting for.
And the last thing I want to add is I want to congratulate you. You're now a senior hurricane specialist at the National Hurricane Center. I believe there's 5 or 6 senior specialists, and then some specialists that work below you guys. How long have you been at the Hurricane Center now?
So I started as an intern at the Hurricane Center in the summer of 2000. So we're 21 years now. So it flies faster than you think. You see the good and the bad. I was there, for the landfall of Katrina, and it doesn't seem like it was that long ago. And I don't care to ever see anything like what happened last year. That was absurd. Putting that ridiculous hurricane season on top of COVID is that wasn't nice of Mother Nature.
No, and it goes to figure that it went that way. Well, we're in good hands. I want to let everybody know on the Gulf Coast, because we've got a super senior hurricane specialist, Eric Blake, local boy who's in Miami helping to protect us. And not to mention the Hurricane Center Director, Ken Graham, who a lot of folks know, who spent years down here with the Weather Service. And of course, my pal and your pal, Matthew Green, a New Orleans boy who works for FEMA. He's the embed at the National Hurricane Center. So we got a lot of eyes on us here in Southeast Louisiana. Eric, thanks so much for being on the podcast today. And here's to hoping for a somewhat quiet season, but we'll be ready for whatever comes our way.
We'll be ready, and I want to have a record out to sea year. That's my goal.
Fish storms all the way. Thanks again. Some great observations today from Eric about where we've been with hurricane season 2021 so far concerning Claudette and where we could be going. I can't say I exactly like what I was hearing from him. Obviously, he's concerned that we could have another active season, and most of the seasonal forecasts are calling for above normal activity in the Atlantic. I can't let today go by without talking a little bit more about Claudette, and not Claudette that we had last week, but all the Claudettes that we've had over the years. Now, this was an interesting fact that I got from Dr. Rick Knabb, who used to be director of the hurricane season, is now on the Weather Channel. He had tweeted a couple of weeks ago and said, of all the names on the 2021 list, Anna and Claudette are the only 2 that have been used all 7 times that list has been active. And the modern list of Atlantic names began in 1979. And so we have 6 lists. So every 6 years, these names repeat. And then Dr. Joe DeLeo of Weatherbell Analytics, he did a breakdown of all the tropical storm Claudettes. The first one being obviously 1979, More on that in a minute. Hurricane Claudette in 1985. That was a long-lived hurricane that was out in the Azores in the eastern Atlantic. 1991 Hurricane Claudette was a Category 4 that stayed out over the ocean. That was a fish storm. Then in 1997, Tropical Storm Claudette just kind of sat over the open Atlantic as well. So 85, 91, 97 weren't impactful. 79 was. I'm going to get back to that in a minute. In 2003, I remember this Hurricane Claudette. That was a strong hurricane that hit near Port O'Connor, Texas. And then in 2009, we had a Tropical Storm Claudette that formed south of Tallahassee and headed into the Panhandle near Santa Rosa Island. 2015, Tropical Storm Claudette was a short-lived tropical storm off the coast of North Carolina that dissipated. And then finally, we know about Tropical Storm Claudette in 2021. Now, what about 1979? In 1979, David was 10 years old in Houston, Texas, and the first ever Tropical Storm Claudette made landfall on the upper Texas coast. The 24-hour U.S. rainfall record was set with Claudette. In Alvin, Texas, which is a suburb of Houston, 43 inches of rain fell in 24 hours, and that was a record that still stood for the United States 24-hour record until 2018, when on the island of Kauai, a location there recorded 49.69 inches of rain, breaking the Claudette record. Well, I call that a bogus record. And here's why I think the Claudette record from 1979 should still stand, or at least there should be an asterisk. The flooding that was on Kauai, the extreme rain of 49.69, was caused by a mechanism called orographic lifting, when you get air moving up the side of a mountain, which causes excessive rising and for lots of rain to repeat over the same area. You see this in the Rockies a lot. It's not the same as just getting 43 inches of rain falling on flat land. So it's two different precipitation processes, in my opinion, and so I think those should be separated out. But that is the history of Claudette, and they weren't retiring tropical storm names back in 1979. In 2001, Allison, that hit the same area, the upper Texas coast, and then eventually southeast Louisiana, where we had almost 30 inches of rain in Thibodaux. Because of the extreme rains in Allison, even though it wasn't a hurricane, it caused so much damage. Allison became the first tropical storm to ever be retired. They probably should go back and retroactively retire Claudette from 1979, in my opinion, especially since it's been used so many times now, but that being obviously the most impactful. Okay, I'm off my soapbox. That's going to conclude episode 11 of this week's podcast. Coming up next week, we're going to talk a little bit more about flood insurance and wind and hail storm deductibles and how those get triggered in a storm, and exactly what your threat is from being flooded every year. I think a lot of people don't realize how high the risk is, particularly in South Louisiana and along the Mississippi Gulf Coast, to have a disastrous flood, a catastrophic flood, impact your property each and every year. Until then, everybody, stay safe. We'll keep you updated on the tropics, and I'll see you on TV on Fox 8.